बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम। सो हम इस डिस्कशन के अंदर प्रूव करने लगे हैं द पावर रूल ऑफ डेरिवेटिव्स डिफरेंशिएशन, जो कि कहता है कि अगर हमारे पास कोई फंक्शन है एफ ऑफ एक्स इक्वल टू एक्स पावर एन, तो फिर उसका जो डेरिवेटिव बन जाता है वो बराबर होता है एन टाइम्स एक्स पावर एन माइनस वन। ये हम प्रूव करेंगे यूजिंग derivative by definition. So before we prove this, I will state a formula that is from basic algebra. So formula reads this: if we have a plus b and you are taking power n, this is equal to a power n plus n times a power n minus 1 b plus n times n minus 1 times a power n minus 2 b square, and then we have 2 here, so on. So you can look for this formula on internet. Then we have p power n. Yeah, so that's how the formula looks. So हम इस formula को इस्तेमाल करेंगे. Well, so let's start the proof. We will consider this function f of x equal to x power n. Don't forget that this n is a positive integer. What happens if n is negative integer? We will talk about it later on. So f of x equal to x power n, because this formula is valid for n positive integer. So we also need f of uh, x plus h, which is equal to x plus h power n, which can also be written as x power n plus n times x power n minus 1 h plus n times n minus 1 divided by 2 x to the n minus 2 times h squared, and blah 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 till h power n. So that's basically because of this formula. So ये formula इसको इस्तेमाल करते हुए f of x plus h इसके बराबर है. Then we can write down the definition of the derivative, which is given by limit h tends to 0, f of x plus h minus f of x, and all of this divided by h, जिसको हम ऐसे लिख सकते हैं limit h tends to 0, then f of x plus h is this guy over here, this is over here. So I can write x power n plus n times x to the n minus 1 h plus n times n minus 1, all of this divided by 2 x to the n minus 2 h squared plus blah 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 h to the n and minus x power n, because we also need to insert the value of this f of x, and all of this divided by h, right? Then we can write it after simplification. h tends to 0. हम क्या कर सकते हैं अब? This x power n gets cancelled with this x power n. So what we are left with? We are left with n times x power n minus 1 times h plus n times n minus 1 divided by 2, and then x to the n minus 2 h squared plus till h to the n, and all of this divided by h. दिस इज बेसिकली है। देन इसके बाद हम इसको लिख सकते हैं लिमिट h टेंड्स टू 0। ऊपर अगर हम h कॉमन लें तो हमारे पास रह जाएगा n x to the n minus 1 plus n times n minus 1 divided by 2 x to the n minus 2 h plus blah blah h to the n minus 1 bracket closed, and then all of this divided by h, and then इस h को इस h के साथ cancel out कर सकते हैं, and then we are left with limit h tends to 0 n times x to the n minus 1 plus n times n minus 1 divided by 2x to the n minus 2 times h blah blah till h to the n minus 1। अब पहले टर्म को छोड़कर सब टर्म्स के अंदर h मौजूद है, इसके अंदर h मौजूद नहीं है। दिस टर्म के अंदर इन द टर्म, इस टर्म के अंदर h नहीं है, बाकी हर टर्म के अंदर h मौजूद होगा। तो जैसे लिमिट अप्लाई करेंगे तो वो जिस जिस टर्म के अंदर h होगा वो सारे जीरो हो जाएंगे। So these will be 0 and we will be left with n times x to the n minus 1. Or I can conclude that the derivative of my function x to the n, ये derivative बराबर हो जाएगा n times x minus 1. So now you can use that into, you can use it at many places, like if we have f of x equal to x power 2024, then my derivative will be equal to n को आगे ले आएंगे, x to the minus 1 means 2023, so on and so forth. What will happen if our n is, negative? Then we can talk about it later on. But what happens if our f of x equal to x power n, और ये n जो है, this is negative, let's say this is some negative integer, what will happen then? If it is negative, then we can write it f of x equal, if it is negative, then k equal to minus n, or if it is negative, then I can write this n to be equal to minus k, or we can write it x equal to minus k and then 1 over x power k, and then we need quotient rule. But since we haven't discussed quotient rule, so first we will discuss quotient rule and then we will be coming back to proving this. Thank you.